Amorphous high polymer plastics, for example thermoplastics, can be deformed plastically as well as elastically with the impact of mechanical forces. The phenomenon of viscoelasticity can be observed in the elastic expansion area here. A small experiment explains this phenomenon. Let us consider a rod that was deformed by a certain amount of stress. On release from the stress, the rod first shows a reversible deformation behavior, which is composed of a time-independent and a time-dependent component. Directly after the release of pressure, the rod is reformed immediately by the elastic component. This resilience can be traced back to the fact that the covalent bonds stretched elastically earlier return to their initial position in the chain. This area of elastic deformation is also called elastic energy deformation. Subsequently, there is a further delayed time-dependent reduction in the expansion. It is because the entire sections of chains are oriented during the expansion. After release from the stress, the chains slide back slowly to the initial position. We call this time-dependent reversible deformation as elastic entropy deformation. Insofar as a plastic deformation has taken place during the stress in the rod, the expansion does not reduce in the initial value. An irreversible plastic deformation component remains. The cause of the plastic deformation is the change in the chain positions, which expand and turn and slide past each other under the influence of the stress. An unbundling of chains becomes noticeable. These processes are not reversible after release of stress.